Today we're going to look at some basic trigonometry functions and learn how to solve for an unknown when we're given either an angle and a side or two sides, and solving for that unknown variable. So if you look here, we have a acronym Sohcahtoa, and many of you have heard this before for trigonometric functions. This SOH stands for sine equals opposite divided by hypotenuse. CAH is cosine is equal to the adjacent divided by the hypotenuse, and TOA is tangent is equal to the opposite divided by the adjacent. And what these are essentially mathematical relationships whenever you have an angle on a triangle and the sides of a triangle. So it says solve for x for numbers 1 through 3. So we're going to do number 1 together and let you do 2 and 3 on your own. We're given an angle measurement here for this particular angle. We're given this side, and this is our unknown side. And if I look based on the shape or geometry of the triangle, here's my right triangle, and across from the right triangle is always the hypotenuse. And then I look at my angle that I have a measurement for, which is 50 degrees, and the side that is across from it, see how that's right across? This is the opposite side in relation to this angle. So this is the opposite. This side, which we don't know either, down here is next to this angle. It's connected to it, or next to, and that is the adjacent. That's what adjacent means, to is next to. So if we look at this, we know the opposite side, we are looking for the hypotenuse, and we have an angle, which is what this theta symbol is. Theta is Theta. It's a Greek symbol. So if I'm looking at my equations, which one has an angle measurement, a hypotenuse, and an opposite side with it? And if you look, it is this one right here, which is the sine of my angle. So I'm going to use that equation. So I'm going to start off with my blank equation. Sine of theta is equal to the opposite divided by the hypotenuse. I then can substitute or solve at this point. In this case, I'm going to solve because I'm going to solve for my hypotenuse, so I'm going to solve this equation for hypotenuse. And it's very similar to the algebra review we just did. So if I'm solving for hypotenuse, which is x down here, I'm going to move it across the equal sign on a diagonal and move sine of theta across the equal sign down across the diagonal there. So here's what I get. I get hypotenuse is equal to opposite divided by the sine of theta. Everybody see that? Move hypotenuse up here, sine theta down there. To get this, now I'm going to plug in my values. X is equal to the opposite, which is 5.0 centimeters, divided by the sine of 50 degrees. Solve for x. Get out your calculators. And go ahead and put that in. So I'm going to put in 5 divided by, and in this calculator it does not have a display that I can see across the top. It just puts it in right here. So I have to input this a little differently on this calculator. I have to put in the 50 first and then hit the sign key. So I'm going to type in, so I already hit 5 divided by, I'm going to type in 50 and then hit the sign button, which is right here. And when it does that, it takes the sine of 50. Make sure that your calculator is in degree mode. If you have a graphing calculator, it's default to radians, so you have to change that over. Click the mode button and then scroll down and you'll see radians and degrees for your angle measurement. Make sure it's degrees. So this is the sine of 50, and when I hit equals, it's going to finish the operation of the 5 divided by that. And if you divide by a smaller number than 1, it should give you a bigger number overall, so this should make sense. 6.527 is the number, and again it's centimeters because of my units here, but let's look at digits. 5.0 has 2, and 50 has 2, so my answer that I report is going to actually be 6.5 centimeters. Good to 2 digits. And that should make sense. It's the hypotenuse. It should be longer than this side. Let's move on to number 4. Number 4, we're going to solve for theta. So theta is here. Think about what sides we know. Across from the 90 degrees is the Good. Hypotenuse. Next to the angle is the adjacent. So what trig function are we going to use that has adjacent and hypotenuse and angle? You see it? Good. Cosine. Again, we're solving for theta. So how do we solve for theta? We're going to take the inverse of this. So if we look in our calculator, you'll see cosine is right here, and if you look right above it, typically they have the inverse function that undoes what the cosine does. And you can see it right there. It says cosine minus 1. So that's the inverse cosine, or the arc cosine function. So when I do that, I show it just like this. So I have the inverse cosine of the adjacent side, which is 6.00 centimeters, divided by the hypotenuse, which is 8.0 centimeters. So in my calculator, here's what I'm typing in. 6 divided by 8 gives me a value, and I'm going to do the inverse cosine. So I'm going to hit second, which is the blue button, to get that cosine minus 1. And it gives me a value. And now I'm going to look at digits before I write it down. 3 digits, 2 digits, answer has 2 digits, 41 degrees. And that should get you started and going through this sheet. Thanks.